My name is Daniel Jacobson. I'm a program manager on the Visual Studio team, and my team is responsible for Windows platform developer features. So my team built the tooling for any sort of universal Windows platform development. Today I want to take you through where the universal Windows platform is at, and I want to show you how you could build a cloud-connected universal Windows platform end-to-end solution leveraging multiple of the Windows 10 device families. So, as I'm sure many of you are already aware, one of the big promises of the universal Windows platform is that you can write an application just one time and run it on any one of the Windows 10 devices. And that includes IoT devices, Raspberry Pi 2, Raspberry Pi 3, phones, desktops, laptops, HoloLens, Surface Hubs, Xboxes, you name it. And it's really powerful, and I want to show you how you can use device family features to leverage the power of that. In addition, I want to show you how you can build a cloud-connected solution leveraging the tools in Visual Studio and the power of Azure. Before we get into all the demos, though, I want to give you a brief history of .NET with the Universal Windows platform and tell you how we got to where we are today. So I'm sure many of you have a longer history with .NET than even myself, and you're probably pretty familiar with many of the .NET platforms. So what Microsoft has a history of doing is building multiple platforms that are all kind of similar, all built on top of the same set of technologies, .NET, but that are all slightly different. So you would have your classic Windows desktop applications built on the Win32 app models, whether it's WPF or WinForms. Then you'd have your Windows Store rolled around with Windows 8 and Windows 8.1. And things would be slightly similar, but your skill sets wouldn't transfer one-to-one. Then you had Windows Phone and ASP.NET 4 and ASP.NET 5. Well, what we're trying to do now, where we're at today is we're really supporting three major .NET frameworks. There's the traditional .NET framework, which is the big framework that many of you are already familiar with for classic desktop applications. Then there's .NET Core, which is what powers the universal Windows platform. .NET Core is a more modern, modular, open source version of the .NET framework that is adapted for modern application needs. And then you have Xamarin, which I'm sure you are all aware is a recent Microsoft acquisition that runs on the Mono-based runtime, which again is more modern, cross-platform, and open source as well. So what I want to talk about with these frameworks is the biggest differences that it means to you as a Microsoft solutions expert. With the traditional .NET framework, what you had was you had to build for your customers. So many of your customers might even still be on .NET 4.5. They aren't adapting the latest .NET technologies on their devices, and that means you can't migrate your application to leverage the latest .NET technologies. Well, with .NET Core and with Xamarin, the .NET framework is actually shipped as a part of the application itself. And what that means is if your customers are still hesitant to upgrade, and for good reason, you can go ahead and just target the latest version of the .NET technology you want to use, and it'll get packaged as a part of your application. So you're no longer tied to their schedule. You can use whatever .NET technology you please, and it'll just ship with your application. It's really powerful. With shared code in the past, you had a different base class library and core library for each of these different frameworks, and we had the portable class library technology. And what portable class libraries allowed you to do was it allowed you to specify a target set of platforms or frameworks that you want to share code across, and then it would filter out any of the APIs that are not shared, that are common across those different frameworks or platforms. Now this was really excellent. It allowed you to share code across many different applications, whether it's server-side or client-side, and it was really powerful for its time. But we think we've come up with a better solution going forward, which is the .NET Standard. And the way the .NET Standard library is different than portable class libraries is you no longer are going to target very specific platforms or very specific frameworks. You're going to target a more general, broad version of the .NET Standard library that will exist forever, and it'll version over time. And as it versions, more and more .NET APIs will be available. And as platforms and frameworks evolve, they may adopt later versions of the .NET Standard. Now, if you just do a quick search for .NET Standard, you'll be able to see the mapping of platforms and .NET Standard library versions. But the real benefit to .NET developers with .NET Standard is that you're learning a technology. You're not learning a platform anymore. So when you become an expert in .NET Standard, those skills will transfer across every single platform that supports that version of the .NET Standard library. So you could be an excellent Universal Windows Platform developer, and since Universal Windows Platform development is built on top of .NET Core, which is very similar to the Mono runtime, you're also a really strong Xamarin developer, even though you may have never done Xamarin development before. And you're also a really strong ASP.NET Core developer. So you'll have the skills to build cross-platform client and web applications just by learning the technology for one of those platforms. It's really powerful, at least I think so. And what I want to show that in use to demonstrate where we're at today is how similar Universal Windows Platform, the .NET Core framework, is to the Mono framework. So with that, we're going to get into the first brief demo. This isn't a Xamarin talk, so we'll just highlight some of the powerful shared code aspects. But I want to jump into Visual Studio to show a sample Xamarin application. So Xamarin Evolve is a conference hosted by Xamarin every year in Florida. And for the conference this year, they developed a conference application, a cross-platform mobile application for any conference attendees to view the schedule, the location, the session information, submit evaluations, et cetera. And what they did was they demonstrated the power of Xamarin in their own conference app and open sourced it on GitHub. So in my app, I can see I have 3 main targets: Android, iOS, and Universal Windows. And if I expand my Universal Windows node, almost everything is assets. The only actual classes I have in here are a helper class for toast notifications, and then the artifacts of the platform that are built into every Universal Windows Platform project. So mainpage.xaml, mainpage.xaml.cs, and then app.xaml, which is going to be up here. That's it. That's all of the platform-specific code. So now if I go to the shared folder, and I take a look at the shared portable library, I can take a look at, all right, here are my view models. Here's what actually powers my application. And take a look at that. So all of that code is what's shared across all of the platforms. Not only that, but the developer of this application, who's actually here, James Montemagno, did an analysis on all of the code in this project to determine how much was shared across each of the platforms. And what really struck me as amazing was the Universal Windows Platform application only has 1% platform-specific code. Since .NET Core is so familiar to Mono, the coding that you're doing for Universal Windows Platform applications could be a great jump start into your cross-platform mobile application. And then it's simple to take that code and share it across the other platforms, where you might have to do a little bit more native coding. As you can see, Android had 10% specific, platform-specific coding, and iOS had 7%. Further, they also shared about a quarter of the code with the server backend. So as you would expect, you can share out many of your .NET models with an ASP.NET Core application. It's pretty simple to do. And what we're going to do is we're going to go through an end-to-end, just Universal Windows Platform part of this, from server to client and sharing some of the code. Let's jump back. I'm going to close this for now. I can only run so many instances of VS on my Surface Pro 3. So now that I've given you kind of the history of .NET, where we're at today, and where we're going with .NET Standard, I want to talk about some nuances with .NET and the Universal Windows Platform. So these are some features with .NET that are exclusive to UWP at the moment. The first one is I mentioned .NET Core is delivered as a part of your application. It is no longer a desktop framework. It is an application framework, if you will. And it's delivered as a set of NuGet packages. And what that means as a developer, if I want to update the version of .NET Core that my application targets, it's just as simple as going into the NuGet package manager, checking for updates, seeing if there's an update available, and updating that package. Just like that, I've updated it. Not only that, but if for some reason one of the .NET Core libraries that you depend on in your application has some sort of issue that is impacting your application, and since it's open source, you already know that a fix to that library has been published and pushed in a pre-release version of the library, you can go ahead and select that Include Pre-Release button in the NuGet Package Manager and go ahead and include that in your application. So you're not waiting for the next release of the framework, which might be 6 months, a year from now. You're waiting for, all right, you raised the issue in GitHub, it got fixed, the pre-release library is available, you add it as a part of your application, and you're good to keep going. So .NET development is much more rapid than it ever has been before. The other thing is .NET Native. I'm sure many of you have heard the term. Hopefully you're familiar with what it is. But with Universal Windows Platform applications, all .NET applications that are published to the store will always be compiled with our technology, .NET Native. And what that does is it takes your intermediate language binaries, the binaries that are compiled from C# to MSIL, that would then be compiled with the JIT in the past, and it actually compiles them one step further to native binaries that will execute on the target device. What that means for you is there is no JIT compilation at runtime. There's no CLR. It's just a 60% faster startup running the native binaries. And we've had quotes from customers saying that it saved them months of performance optimization work that they traditionally would have had to do in their .NET applications. In addition, we've observed about 40% lower memory usage with a .NET native binary compared to the MSIL binary. And again, applocal.net. I mean, I want to stress how huge that is. Like, you no longer are waiting 6 months to a year to target the latest and greatest .NET technologies. Now, with .NET Native, the traditional developer workflow is modified just a little bit. And that is because .NET Native only executes in release mode by default. You can change your build configuration settings however you'd like, But by default, debug actually does MSIL compilation, creates MSIL binaries, and runs against the JIT to speed up compilation time, to give you more useful debugging information, and to improve the developer experience as much as possible. Then when you're getting ready to publish and release the application, .NET Native comes into play. However, since .NET Native is a relatively new technology, I mean, the platform has only been released for a year now, there are still hiccups every now and then, and they've actually decreased quite a bit since we've released the compiler. They've done a really good job at finding the most impactful issues with the compiler and fixing them right away. Every now and then, though, you might get some odd runtime behavior because you're missing some type information that was stripped from the compilation process, or you might even get a compilation error if you're trying to do something that's unusual. And what this means is that you should typically test in release mode about once or twice every day, just in case you don't want to end up being the guy or the gal who builds an app for 6 months and then tests in release mode and something breaks. And now you have 6 months of code to dig through because you never tested release mode in the past. Whereas if you test once or twice a day, you only have a couple hours of code to dig through. Finally, as I mentioned, the store does the .NET Native compilation for you. So when you're actually getting ready to submit and publish the application, it's important that you publish the Apex upload package. That will include all of the store metadata you need for store submission, as well as the appropriate MSIL binary package, because the store will then further compile it to .NET Native. And the reason the store does the compilation is just in case there were any sort of issue with the compiler that we observed after a whole bunch of apps have been submitted, we have the flexibility to fix that issue and recompile the apps because we have the MSIL source. Now, this hasn't happened. We don't ever expect it to happen. But the last thing we want to do is tell all of our developers, hey, we think you should probably reconsider submitting your app again when we could just do it ourselves. So with that, I just wanted to get into the demos. So let's build an app for the rest of the time. I think you guys are most interested in seeing Visual Studio. So recently, a friend came to me saying they wanted to open up a coffee shop. It's stereotypical Seattle, coffee everywhere. But they wanted to optimize their chances of success. I mean, starting any new small business is always a risky endeavor. And in order to optimize their chances of success, they wanted to be data-driven about it. They wanted to use technology to be able to analyze the progress of their store effectively. So some of the questions they wanted to be answered were, how many people are currently in my store? If I'm the sole employee at the time and I'm busy ringing someone up, and I want to see how busy am I at the moment so I know how fast I should be processing things versus making small talk to improve customer experience, well, it's important for me to have that information really handy. How can I tell when someone enters my store and I'm not around? What if I'm in the back doing cleaning or inventory or bookkeeping and I want to greet the customers? I mean, in order to have a successful business, I need repeat customers. How many people enter throughout the day and what time is the busiest day? So I know, do I need to hire additional help and at what time is it at what time does it make sense to hire them? And again, what is the busiest day of the week? Maybe I need more employees on the weekend. So in order to build this, we can leverage .NET technology across the Universal Windows Platform, ASP.NET, and using the power of Azure. So the design we have an IoT device that we can leverage Windows 10 on that is effectively just going to track, did someone enter or did someone exit my store? That's all it needs to do. And as soon as it does that, it needs to send that information to a REST endpoint that's listening for that. The REST endpoint is then going to communicate with Azure to write it to a database, and then actually send a push notification down to my client application. So I know, hey, someone entered your store. If I'm in the back doing bookkeeping, I probably should get out there. When the client application, the desktop or mobile application is launched, it's going to, again, send a notification to my Azure web app. So it's a REST endpoint, a GET message, to read from the document and send me a list of all of the events. And then from that list, I can do some processing and visualize it in a meaningful way in the UI. So I can, at the end of the day, take a look. How many people entered today? What was the busiest time of the day? What was the busiest day of this week? Et cetera. So let's just go ahead and get started. Close that. So in Visual Studio, I have a completely empty solution. We're going to start from scratch. However, it's difficult to build the entire thing in an hour, so we're going to leverage some pre-written code. So the first thing I'm going to do is add my shared code that's going to be shared across all of the different projects. So I'm going to add existing project, desktop. And we'll just take a quick look at the contents of the portable class library, but it's nothing too complex. Whoops. In the resources folder, I have all of my Azure keys that are needed to communicate securely with my Azure services. In models, I just have a couple of objects that are declared. And the one of importance is the triggered event model, which has two properties, event type and event time. So that's what I'm going to be tracking throughout the entire solution. It's a list of these when I want to visualize it. It's a single one of them when an event is triggered, et cetera. So nothing too complicated there. The next thing I want to build is actually the ASP.NET application. And since this is mostly a universal Windows platform talk, we're not going to spend too much time on it, but I want to show you the powerful tools in Visual Studio that make it really easy to build and publish and iterate on these applications. So we're actually going to start from scratch, File New, so you can see what it's like. I'm going to select Web, ASP.NET Web Application. And I'm going to call the application Event API. Whoops, I want File New Project, not New Solution. So Web, create directory, no solution name, create new solution. Add to solution. There we go. So I'm going to select Web API, and I'm actually just going to select ASP.NET 4.5.2, and I'm going to choose not to host in the cloud. If I selected to host in the cloud here, what Visual Studio would do would prompt me to create a new service running in the cloud that could then host this web application. For this demo, I have already created the service, but that's just one of the tools in Visual Studio that makes it so you almost never have to leave the IDE. So go ahead and create that. And the first thing I'm going to need to do when this is created is add in the controller that I've already written, the web API that's going to listen for the get message to return a list of all the events from my database, or the post message to write a new one. So in Event API, I'm going to add an existing class to controller, and we'll take a look at that. So event controller class. So let's just briefly take a look at the contents of this class. Again, for simplicity, I tried to put everything in one class, so it's easy to demo. I can see I'm missing some references. The first one is my portable class library. So let's go ahead and resolve that one first. Now, one benefit of the .NET standard that you will immediately observe is that when I try to add a reference to this portable class library, because I picked discrete targets, and .NET 4.5.2 was not one of them, the reference fails to add. So the way I fix this today is by going to the properties of my application and changing my target. And I could either change the target of my application or change the target of my portable class library. With .NET Standard, I would just ensure that I'm picking a version of the .NET Standard library that supports all of the platforms that I want to build on, and that would not be an issue. So now that that target is added, now let's add the reference to the PCL. And now in controller, I can resolve those. So the other references that I need to add are both NuGet packages. And one of the things that NuGet has been doing is they've been improving their search optimizations. So if I just search in document DB, which is the one I'm interested in, it comes up, I think, as the fourth one. There we go. Yep, fourth one. So I can go ahead and install that NuGet package. Now this will take a second, so let's walk through the code as this is installing. In the class itself, I have several just Azure keys and names that I'm calling in from my resources file that are going to let me interact with my document and my, just my document, really. And then I have the methods that I mentioned, my get method, which is, there we go, which is just going to simply read all of the triggered events from my document database that's hosted in Azure and return a list of all of those events. So as you can see, triggered events is an I list of triggered event. I'm going to return them, and that's all I need to do. Simple method. Post is going to create a new event that's then going to upsert it into my document database collection in Azure. So that's all that's going to do. And then inside of here, I have a couple additional helper methods. I have a trigger push notification method, which will send a push notification to my client device. And then I have a get document response helper method, which is just some shared code across both the post and the get method. And that's really all it is, 120 lines of code to build my server. So the only other reference I'll need to add is for push notifications. Notification hub should be all I need to search. Microsoft Azure notification hubs. So now what I want to do is I want to go ahead and test and make sure that this is actually working first before I publish it to my live service. So let me first make it my startup project. I think the NuGet package is still resolving. There we go. I accept. So for NuGet, I will deploy it directly to Microsoft Edge, my local browser, and I'll place a breakpoint in my controller to make sure everything works as I would expect it to. So I'm actually going to send a post to my local host to make sure that I'm receiving a push notification. This device was previously registered for my push notification service. And I want to also make sure that the information gets written to my database. So let's place a breakpoint here, make sure everything gets hit. I will remove Solution Explorer for now. And I'm using Postman, which is just a simple web debugging tool that lets you send HTTP requests, for those of you familiar. So localhost 3495 / API event. And the event I'm sending today is August 10th. And let's make it 20 o'clock. So 8 p.m. Global Standard Time is when this event occurred, and it's true. It means someone has entered the store. So go ahead and hit send. I immediately hit the breakpoint so I can debug my service right away. I can view my variables, just like you would expect in Visual Studio. And then I can go ahead and create my push notification at the very end and make sure everything works as I would expect. So my response is success. I see someone has entered the store. I get a notification on my desktop. And then in the Azure portal, I can actually inspect the contents of my document. Now, there's actually a tool that's in preview for you to be able to do this directly in Visual Studio, but since it's in preview, there's still some issues. So in the next release of Visual Studio, you should be able to view the contents of this document directly in your Visual Studio editor. You should also even be able to edit the contents of this document. So if you want to do some database development and testing, it's very simple to do without ever having to leave the IDE. So I can see this event was successfully added, and I'm good to go. So the next thing I'll do, just to make sure everything is working as I would expect it to, before I publish this, is I'll do a get method. So it's loading. Oops, first I have to continue. I never got the full response. There we go. So now let's try my get method. It should just return my single event because I only have one at the time. Great. I'm pretty confident my ASP.NET application is working as I would expect. So now I want to deploy it to my Azure service live. So part of the Azure Tools gives you the Cloud Explorer, which lets you inspect all of your different Azure services. And what this will let me do is it will let me find my live running service and attach a debugger to it. Whoops, I forgot one step. Whoops, I had to publish it first. So first, let me actually right-click on my project. Even without the Azure Tools, you're able to publish your service directly to Azure. So I can go ahead and select a publish target, Microsoft Azure App Service, Shop Analytics Demo, Shop Analytics Service, OK. And then I could hit publish right there, and I'd be good to go. That would be a production publish. But since I want to attach a debugger and do live debugging of a live running service in an Azure VM, I actually want to make this debug for now. So let's go ahead and hit publish. This should now publish my service. And as I mentioned, I can inspect all of my Azure resources in the Cloud Explorer to view that live web app, which will take just a second. So Shop Analytics Service, as I would expect. As soon as the publish finishes, I will go ahead and attach a debugger to my live running service. So that should go ahead and finish. Whoops. I'll right-click, attach debugger. And now I'm going ahead and I'm attaching a debugger to a live running service in Azure, and I can go ahead and send a post method to the real server. So this is what I would expect to actually happen in production. So Shop Analytics Service. So the one thing I will have to change when I do send the post is I'm going to have to change the base URI since I'm no longer debugging on my local host. I'm debugging a live executing service. And I will do post again and get again just to make sure everything works. It is ready. So here's post. I'll hit the breakpoint once again, make sure everything works as I'd expect. Send. I can see my new event. Again, is 20 o'clock Global Standard Time on today, and it is true. So I'll hit F5 to continue execution. I get my response, which is the single event. Whenever I submit a response, I have it returning just the event that was added. I get my push notification. And if I return to my document in the Azure portal, I can refresh it and see now I have 2 events. Another way I could check to see if I have 2 events is just by sending a GET message to that same service. And now I see that 2 are returned instead of 1. Perfect. So that's building my web API using Azure to host it and attaching a debugger to the live service. And now I want to actually build the universal Windows platform applications that are going to leverage this service. So I'm actually going to start with a new instance of Visual Studio, and I'm going to leave the debugger running for that service. Later on, when I debug my IoT application, I want to make sure everything is working together, both the server and the client. So let's open up the solution. And again, we're going to start from scratch. I'm going to add a new universal Windows platform project to build my IoT application, which is going to be able to write events to my document in the cloud. So add new project. Windows Universal. I'm going to call this IoT client. As soon as I create my project, I can see I'm greeted with which SDK do I want to target. So I have the 10.586 SDK and the Anniversary Update SDK installed. And I'm actually going to choose to target the Anniversary Update SDK. I like the latest stuff. For now, I can close the Cloud Explorer, minimize this for convenience. And for those of you who were at Nick Landry's talk earlier today, what you'll recognize with IoT development is a lot of the code is just boilerplate initialization code for the hardware that's on the device. Depending on how complex your device is, that could be quite a bit, whereas the logic itself is pretty simple for my app. So in mainpage.xaml.cs, I'm going to go ahead and add some existing content. Snippets, IoT. And we'll walk through what all this means, but none of it actually does any logic. It just gets the board ready to go. Close my Solution Explorer. So as I can see, the first thing I'm doing is I'm referencing the key, which is the base URI of my Azure endpoint, to be able to send a post message. So I'm going to first have to add a reference to my portable class library. And my portable class library already does target the Universal Windows Platform, so that resolves instantly. GPIO, or General Purpose Input-Output pin, is an object that's in the Universal API set, meaning I do not need to add a reference to any extension SDKs for this application. Now, if I wanted to take advantage of more advanced IoT APIs, I have the option to reference the IoT extension SDK, and then I could write adaptive code so that it only executes if it's on an IoT device. But for this demo, I don't even need to do that. The Universal API set is pretty complete. I'm going to have to add a reference to my portable class library. So what I'm doing here is I'm defining the pins that my hardware is connected to. And this would be a good time for me to explain the hardware a little bit. So for those of you who can see it, all I have connected to this device are 2 infrared beam sensors and 2 infrared LEDs, as well as 2 visible LEDs to just be status indicators. So the way I'm going to detect entrance or exit is which way they come through the door. And we'll get there in just a second. What I want to be able to do, though, is I want to be able to see when the sensor is broken. I want the light closest to that sensor to turn on so that I can see, OK, this is working as I would expect it to. So these 4 pins are just the pins that map to those hardware devices on my Raspberry Pi 2. Then I'm actually going to create the GPIO pin objects for the sensors, and whether they're input or output devices will be declared in my pin initialization step. And then I'm going to have 2 Boolean values that are actually going to be used in the core logic of my application. These are going to be used to determine, did someone enter or did someone exit? And I'll walk you through that with a diagram in just a second. Finally, I have my HTTP client, which is going to be used to send my post message to my Azure hosted web API. The last thing that I have that's not resolving, well, second last thing, is GPIO status.text. So for convenience and for debugging, I actually put a text block in my XAML application. Since this is the Universal Windows Platform, I can just write XAML that will execute on my IoT device. And this will tell me, OK, this is actually a device that supports GPIO pins. If it does, say it's initialized correctly. Otherwise, say there is no GPI controller on this device. So I'm going to go ahead to mainpage.xaml, create a single text block, call it GPIO status, and then I'm going to make it really big so we can all see it. Center, font size equals 72. So all I did was created a text block in the very middle of my page with a font size of 72 that will tell me, hey, you're on a device that supports GPI controllers, or you're not. Let's return here. Now, the last 2 things that are not going to let this build are actually my value changed event handlers. So since this, again, is the Universal Windows Platform, handling digital input and output devices is as simple as using value changed event handlers. I'm sure many of you are familiar with event-driven programming, and that's all this is. So I'm just going to go ahead and create these methods for now. I'm not going to put anything in them yet. And I'm going to put a breakpoint here and deploy my application. Whoops. First, I have to set it as my startup project. Now, my Raspberry Pi is a remote machine, but it is an ARM device. So I need to make sure I set the architecture properly. Remote machine. And there we go. So my device is actually automatically discovered as well, since I'm on the same network. So I can just go ahead and select it here. I'll hit F5, and this will take a moment. So while this is deploying for the first time, it takes a little bit longer the first time than it does any subsequent times. I'm going to go ahead and explain the logic of this program on my IoT device. So let's return to the slides. So here's kind of a top-down view of what my device looks like. If you're looking at it this way, you can see my sensors and my LEDs. So entry is the If I were looking at my store, entry would be the sensor that is on the outside of my store. Someone comes into the entry sensor first, and then the exit sensor, and that would be an entry event. So as I can see, when my Ninja Cat riding my T-Rex goes through the entry sensor, I'm going to change the value of my enter boolean to true. That sensor has been broken at this point. Now, I know an event has not completed yet because they've only gone halfway through my door. Now, I know it's a very small gap, but this is how I'm going to determine exit or entry. So as the T-Rex continues, the exit event will fire, and it'll set that boolean to true. Now, what's actually easier to do is to just, when exit is fired, check, is enter true? If enter was fired before the exit sensor was reached, I know an enter event has just happened. So what I'm going to do is I'm going to reset the state of the device, and I'm going to send that post notification to my Azure Web API. Now, since I reset the state of the device, I'm ready for the next person to come in and out. And as you can see, the gap here is very small. And if this were confined to a single doorway, this would be pretty reliable. Now, if this were a big gap, unexpected for a small shop, you could probably add additional sensors that are proximity sensors to do additional logic to determine exit or entry. But for our scenario, we can just deal with the 2 infrared beam sensors. Now let's return, see if it is deploying. So it is registering the application to run from the layout. Let me go ahead and actually switch the device so you can see what it looks like on the Raspberry Pi 2. And one thing you'll notice real quick, the version, never mind. Sorry about that. My OS actually updated automatically, which is pretty cool on Raspberry Pi. It was a week old before today. But the point there is that you can actually deploy an application that has a target platform version higher than your target device, as long as you're not leveraging any APIs that might fail to execute on that device. So you can write adaptive code and always target the latest APIs and build them adaptively so they run on any device always. So I can see my GPIO pins are initialized correctly. Awesome. So let's return to the PC and actually break the beam of one of these sensors. So I expect the value of the digital sensor to change as soon as the beam is broken. So I'm going to do the one that's closest to me, so this sensor. And I hit a breakpoint. So as I can see, that's the exit sensor. My exit sensor value changed as soon as that beam was broken. Close this so you can see. So what I want to do now is I want to see what actually happened when this event was fired that I can use to determine and figure out the rest of my logic. So what properties can I track when the event is fired to see, is it broken or is it not? So if I look at my local variables, I can see arguments, and args.edge is essentially what is happening to the digital value of that input device. In this case, args.edge is equal to falling edge. And this is going to be the value of the sensor as soon as the beam is broken, because that's when the breakpoint was hit. So if args.edge is equal to GPIO pin edge, falling edge, that means the beam is always broken. If it's equal to rising edge, the beam is unbroken. So I can use that knowledge to actually write the logic of this application. So let me go ahead and stop debugging and do just that. So if args.edge equals GPIO pin edge dot falling edge, I can remove the breakpoint for now. And just so I remember, this is beam is broken. My hand is in front of the beam, my customer is walking through the store. Else, beam is unbroken. All right, so the first thing I want to do when the beam is broken is I want to check. In this case, this is my exit sensor. So that's the one closest to me. I want to check, was the enter sensor already fired? Did someone already go through the other sensor? And if that is the case, that means someone is exiting the store. So someone is entering the store. That means someone is entering the store. So if enter is equal to true, execute code, that would be essentially an event. So in this case, I'm going to say customer has entered true. And that's a method that doesn't exist. We'll write it in just a moment. So that means someone has entered my store, and I'm then going to reset the state of my device. So the next time someone walks in, it's ready to go. Now the other thing I want to do is return out of this method so it doesn't continue doing anything. That's the end. My event has gone, I'm done. Now if someone had not already entered the store, that means they are probably in the process of exiting. They've fired this sensor before this one, they're walking out. So what I can do then is set exit equal to true. That one has now been fired. Now the last thing I want to do is I have these LEDs that are going to be used for debugging to make sure my sensors are working properly. I can see because the light turns on. So what I'm going to do now is if the beam is broken, regardless of if an event is fired, I'm going to turn the light on. So entry light dot right GPIO pin value.low. And for those of you who have done any sort of IoT development before, the hello world of IoT is getting an LED to blink. So this is one of the first things you learn how to do, is to turn an LED on or off. So I'm just going to go ahead and copy and paste it. Whoops. This is actually the exit sensor, so exit light dot write GPIO pin value. Got it backwards. So last thing I want to do is now turn it off if the beam is no longer broken. I only want the light to be on when the beam is broken. It's very visual. I can see exactly what's happening. So now I've got that method written. I can essentially just copy and paste and change some of the Boolean values for my entry sensor value changed event. So let's go ahead. This is still going to be the same. This is still going to be the value of the sensor as soon as the beam is broken. They're the same exact pieces of hardware, and they're wired up the same way. I'm going to now change this to entry light. Now, if exit has happened, that means I'm going to send false to the parameter. That means someone is exiting the store. That's how I'm going to create my triggered event object. I'm again going to reset the state of the device, and now I'm going to send enter to true. The last thing I need to change is this to entry light, and we should be good to go. So now what I'm going to do is I'm going to make sure that I create an event as I would expect to by debugging this application. So let's F5 it one more time, make sure that my lights work as I would expect, and when I go from exit sensor, which is the one closest to me, to entry sensor, which is closest to you, that should be an exit event. Someone is walking out of my store. So if you will, you're looking at my storefront, is how this is arranged. Now this will take just a second to deploy. There we go. Let's make sure the symbols load properly. Great. So you might not be able to see it because it's a little bright in here, but first I want to make sure the lights work. So I crossed the red one. For those of you who can see a red light. Oh. Breakpoint wasn't hit. That was weird. So now they're both going to stay lit because the breakpoint was hit. So as soon as the breakpoint hits, the code is no longer executing, so the value changed event handlers are not going to continue to run. So now they're just going to stay on. So hopefully you can see the lights, and that's because my breakpoint is hit. So I can see I went from exit to enter. This should be false when I hover over Boolean value. Oops, it's getting the data type text. False. Great. So now I can see that my event is firing properly. I'm going to throw an exception if I continue to execute the code. So I'm just going to stop. And I'm going to write the code to send my event to my Azure hosted web API. So the first thing I need to do is actually create an event. So I'm going to use the shared code from my portable class library. I'm referencing it across all of my projects. I'm just going to call it E equals new triggered event. And I'll just create the object in the declaration. So event time equals date time.now. Event type equals v. Oops. So my object is created. Now I need to create HTTP content that I can then post to my Azure hosted web API. So HTTP content, post content, string content. And then, so string content has 3 overloaded methods. I'm going to use the last one because I want to specify that I'm going to be sending JSON to my web API. That's what it expects. So the content itself is just going to be e.toString. And before I forget, I should probably fix the syntax of that. E.toString. Nope. And I wrote an overloaded method for my e.toString to just write it in JSON. Encoding.utf8, and then application/JSON is the type of content that I'm going to be sending to my web API. Now finally, the last thing I need to do is post it. So I don't need to worry about the response. I don't need to await this method. I'm not going to do anything with it for the demo purposes. If I were writing this more robustly, I would probably make this an asynchronous method and track the response that I'm getting. But I'm actually just going to blindly await. Whoops. I do want to make it async just so the debugging works. Await client, which is already created, .post async. The request URI is just going to be the URI that is appended to the end of my base URI. So in this case, it's going to be API event, which is user-defined in my code. API event. And then the content itself is going to be post content. Now let's put a breakpoint there, F5, and make sure everything works one last time. And I think this next demo, I think, is one of the most powerful things in Visual Studio. If you're building a end-to-end connected solution, it's really powerful if you ask me. Hopefully you guys agree. Any questions so far? Quiet audience, all right. So if two people enter the door at the same time, you're going to need additional sensors. You could probably leverage ceiling-mounted proximity sensors with some additional logic. But yeah, good question. Great, so it's working. Let's create an entry event this time instead of an exit event. So I'm going to go from this side to this side. So the red light is going to stay on because the breakpoint is hit. The yellow light went off because I didn't hold my hand in front of both of them. I crossed yellow, then red. My event is fired. I should see true now. Someone walked into my store. Just a sec. Good, V is true. Now when I hit F5, what do you expect to happen? So what actually happens is I left the debugger attached to my live running service. So right now, if I put these side by side, I now have client and server debugging side by side. If I had two monitors together and I was trying to diagnose any sort of issues that were happening with my end-to-end solution, I could debug both of them, just right next to each other. So I can view and inspect the values for both of these applications and make sure everything is working. So in here, if I look at my locals, the code is currently in the process of executing, so it's not going to show me. But I can see from here, new event happened at today at 22:55:28, and it is an event type of true. Now, if I continue to hit F5, I should see the exact same thing in the local variables of my IoT application that is also executing right next to it. So I continue the execution here. I should see a push notification in just a second. Oops, I did not continue. I thought I hit F5. There we go. Now I continued. Someone has entered the store just as I would expect. I can go back, take a look at my event here. So event time. Let me just look at locals. Cool. So E event time is again at the exact same time, except this is local time. So the server is processing it in a standard time, whereas this is processing it in my local time, which is going to be 3:55 instead of, what was it, 8:55. I think that's pretty amazing. So for now, I'm confident my web API is working. I'm confident that my IoT application is working. So I'm actually going to stop both of these and close both of these. What I want to show you next is the data visualization app. But not only that, I want to show you some of the tools that are going to be coming in the next release of Visual Studio that make building and debugging and creating performant XAML applications really easy, easier than has ever been before. So I'm going to break out of both of those, and I'm going to open up Visual Studio 15 Preview 4 for now. So inside of my application, I'm going to open up the same exact solution. And again, I'm going to add an existing project. So I've already created the client application that can run on both my desktop, my phone. If I wanted to hook up an Xbox to my store, I could do that too. And we'll see exactly how that works. So add existing project. Snippets. So the one thing that I do want to do before I execute this code, it's not going to look very interesting with, 4 pieces of data. If I refresh this, I can see latest 3 pieces of data. So let me go ahead and add in some fake data. Desktop. So here we go. This will look way more interesting. And the beauty of the tooling for Azure is that I could just go ahead and copy and paste this into my document. Save, done, woohoo. So now when I execute the data client visualization app, I should actually see some data that makes it more interesting. So before we do anything, let's just go ahead and run it and see what it looks like on my local machine. And while that's running, I will get it ready to inspect the code. So all of the interesting stuff here is really in the UI. There's some processing in the back end that filters out some of the events to make it meaningful in the UI. But the UI is really the stuff of importance here. So go ahead and run my app. What you'll see here is it's loading the data from behind the scenes. It's going to show me a progress ring. And as soon as it finishes, I should see some information about my store over the past several weeks. Cannot DC. I probably copied and pasted it in here improperly. Yep, my bad. Save. Let me re-execute that code. There we go. Now hopefully it parses it properly. I should have better reference checking if something parses properly. There we go. Cool. So over the last 5 weeks, I can see some data about my store. How many people have entered? What is the busiest day of the week? What was the busiest time of my day yesterday? It might not be useful information for today, and I could change this however I wanted. I can also see exactly how many people are currently in my store, and if I were to go ahead and send another post message to my application, that should increase by 1. Someone has entered, current people in store 1. So I can view, while this is running, how many people are currently in my store and what's going on. So the layout of this, if you notice, is actually adaptive if I were to make this small. So if I was on my phone device, I could scroll down and see the information as I'd like it to be. And I want to show you how simple that is with the Universal Windows Platform. Let's go ahead and stop the execution for now and take a look at the design of the layout. So for now, I'm going to start with desktop. So the layout that I have here is I have a grid within a grid. I can probably lower this for now. And the first grid is simply 2 columns. I have a first column with some metadata about my store hours, my store name, when the data was last refreshed, etc. And my second column, my second row, I have an additional grid, which is my 4 quadrants. So I have 3 charts and information about how many people are currently in my store. Now, in order to make this adaptive, I had to write about 30 lines of code. So all I did was I'm changing where in the grid these controls live. So I have a couple of essentially dummy rows and dummy columns that will change depending on the width of my screen or my application. So I can see I'm adapting on the minimum window width of 720 effective pixels, which is recommended for smaller screen devices. And then I'm setting the value of some of the rows and columns to essentially host those controls. So from line 37 to line 16 is all of the code that I needed to do to make this adaptive UI work across all device screens, really. So this will work for phone, for Surface Hub, for Xbox, for IoT, whatever device I have, it will always just work. So the next thing I want to demonstrate is some of the new XAML tooling in Visual Studio that is going to be released shortly. And there's already previews available for you to test this out. So one of the things that I don't think looks very good about this application is the title. So we have this new feature known as XAML UI debugging. How many of you are familiar with XAML UI debugging? It's been out for a little while now. How many of you consistently build XAML applications? Wow, all right. So for those of you who build XAML applications, WPF developers get this feature as well. You can go ahead and essentially just build an adorner. How many of you do web development? This should be more familiar to you folks. So effectively, we have the visual DOM in XAML now. So I can go ahead and click on my control. And what that will do is in the live visual tree, which is another new control, it's a new window, it'll show me the entire list of visual elements that are currently happening at runtime. So if I have a data-driven control, like a list view, for example, I can see every list view entry with the properties as well. So if I click in the live property explorer, I can view the current runtime properties of that control. Not only that, let me close the diagnostic tools for now. Not only that, but I can go ahead and modify the runtime properties as I see fit. So if I want to change the font size, make it look a little bit bigger, I can just go ahead, type font size 24, and in my running application, that is now much bigger. So with XAML UI debugging, if you modify properties in the live property explorer, that's only temporary. That's for debugging purposes. And that actually exists in Visual Studio 2015. You can do all of this today. What's going to be new is I can actually go ahead in my source, which I can find simply by, if I go back to here, I can simply click on here to find the source of that control. I can now just start typing font size equals 24 and hit save as my application is running. So I was able to find that control in the visual tree. I was able to modify the local runtime properties of that control, and then I was able to actually edit the document all at runtime. So I can build my UI as my app runs. I can figure out the properties. I can see exactly what it's going to look like at runtime. So if I were to stop this and run this again, I would see exactly what that looks like. And we'll do that in just a second. But before that, I want to show you the next new feature that's going to be coming. So one of the most difficult things, especially for me with XAML development, is adhering to performance principles and performance best practices for building your UI. So one of the other tools that's coming out with Visual Studio, the next release, is what's known as UI analysis. And what that does is it gives you a list of performance and accessibility issues in your application. So as you can see, my app is not very performant. But there's one thing that I do want to show you is one that made me learn something new when I created this app. So as you can see, I currently have 6 warnings about this specific performance issue. Whoops. And what it's telling me is as soon as I start up my application, I'm setting the visibility of some of the visual elements to collapsed, which means I'm just hiding the controls, but it's still loading them in at runtime. So it's still using memory, it's still using processing power to actually create those controls, even though they're hidden to the user. And what it's telling me is you shouldn't do that. You should probably only load in that element if it's needed. And so what this will do at release is it'll give me more information on the issue. But since I work with the team that helps build this, I know exactly how to fix it. So again, if I double click on this, it'll take me directly to the offending control. And as you can see, my application is still running. I haven't stopped debugging this yet. So what I can do here is type in x:defer load strategy equals lazy. And what this does is I'll have to add a little bit of code in the code behind as well, but it will only actually load this control into memory if the control is needed. So let me go ahead and finally stop debugging, go back to the code behind. Let me make sure I'm doing the right name. So current people in store is the name of the control that I'm fixing. Now let me, in my main page, after my data is loaded, I'm going to do this.findName current people in store. And now this will try to retrieve the object. So since I'm doing something that tries to retrieve the object of that name, it's going to have to load it. So now instead of loading it as soon as my application starts up, it'll load it when it has more available resources because the data has been loading in the background. It hasn't needed to use anything else that it was using at startup. So now if I hit F5 again, that warning should go away, and I could repeat the same thing for the other remaining warnings of that type. So if I go to events, so the app looks just the same. Nothing has changed in the visual behavior. Whoops. Every once in a while with preview builds, this happens. But yeah, this is bleeding edge tools. It's always a fun time. Hopefully it recovers. If not, I'll just restart it. Give it 10 more seconds. All right, let's try again. But yeah, so this is one of the tools that, again, on top of .NET Native with the platform, this is another one of those tools that will drive developers to success with the performance of their application. It'll minimize runtime issues, it'll optimize anything else, and it makes it really easy to fix those kind of more complex UI development snags, I guess. So views, let me just go ahead, set it as my startup project. Oops, this is the wrong solution. No. And so we'll try this one more time, and if not, we'll just move on to the final demo. There we go, local machine. I should probably make sure that all of my changes saved as well. And we can just check the events first. All right, let's see if there's only 5 now instead of 6. 1, 2, 3, 4, 5. Oops, maybe it didn't save. I don't want to belabor this too much, but I think you guys understand the point of this. It's going to make it much easier to optimize the performance of your UI. Oh, it did save it. It's interesting. Maybe I did something wrong. That's all right. The last demo I want to show, because we're running low on time, is how you can integrate Hockey App with your application for analytics for your mobile applications. So in Data Client, in Visual Studio, there's this new menu item when you right-click on the project called Hockey App. And Hockey App, for those of you who are unfamiliar, is a mobile distribution platform, or mobile application distribution and analytics platform that enables you to rapidly iterate on your application, submit it to all of your testers. They'll get notified as soon as a new build is uploaded. They can test it. They can provide feedback on it. You'll see all that feedback in one central location. And then you can also do telemetry on your application. So you can fire custom events. You can get crash analytics, etc. Now, this used to be a difficult thing to spin up. Now it's just a couple of clicks. So the first thing I want to do is distribute my application with Hockey App. Now, this is going to guide me through the process of creating an application if I don't already have one, but I do. And then it's going to zip the contents of my package folder, but I haven't already created a package. So again, it'll tell me this is a problem, you need to go ahead and do this. So I'm going to go ahead and very quickly create a package. I'm not going to create a package that I would submit to the store, because that will take longer. So I'm just going to debug x86 package, create. So this should take just a couple seconds. Failed. Oh, I think I know why that failed. My mistake. So when this was in source control, I stripped out the certificate, but you need a certificate to create a package. So this is not part of the demo. I'm going to quickly blaze through this. Okay. Let's go ahead and do that again. Store, create app packages. One thing I also want to do, just so I know, I'm going to create version 2.0.0. That'll come into play in just a moment. Great. This should succeed. And normally when you create a new project, you get access to the pack is denied. So this is the problem with preview builds. This actually works in Visual Studio 2015. Let's return to Visual Studio 2015 for just a moment. See if that'll work more reliably. I don't need this. I just want to open my solution. I should still see the certificate in my package because it was edited in the same directory. Data client. I do have my temporary key. Let's try one more time. See if the build succeeds. There we go. All right, so my package is now created. I have a package. I can view the package in the directory. But what I actually want to do is upload it to HockeyApp. So HockeyApp, distribute with HockeyApp. I'll go ahead and sign in with the right account. I'll hit next. Distribute it with the project data client. This is my actual app. Download is allowed. Next, I can add release notes to this package, which will be visible to HockeyApp as well as the people acquiring the package. I'll hit finish, and then it's going to go ahead and upload it to HockeyApp for me. And so any user that is subscribed to my application in HockeyApp, which could be from an organization or from a list of enthusiastic customers, will then get a notification as soon as this is done. And they'll be able to go ahead and download it. So I can see I successfully uploaded it. Let me go into HockeyApp. So here's the latest version before I did that. Let's go ahead and refresh the web page. I can now see that build 2.0.0 was updated a minute ago. And what I can then go ahead and do is click on that and download the build. I also upload the symbols automatically. It's smart enough to find where the symbols are and upload those. So when I do find crashes, I can go ahead and debug the dumps with Visual Studio. So I'm going to go ahead and download this build and show you one other new feature that's actually part of the operating system with the anniversary update. So open. So here I can see my package. And because of the anniversary update of Windows, all I have to do to install this is double click on it. If my security policy lets me run anyways. So just like that, I can go ahead and install. It's going to tell me my system administrator doesn't allow that certificate, but if I actually had a trusted certificate for this application rather than my test certificate, which most developers actually do, it would be as simple as that. Now the last thing I want to demo is how easy it is to get started with crash analytics with HockeyApp. And this is really, really powerful. So when I want to enable crash analytics with HockeyApp, I've already distributed my package once. All I need to do is click Enable Crash Analytics and give me the application name and hit Finish. And what that does is it'll add a single line of code to my app.xaml.cs file. It'll reference a NuGet package, and that's it. And not only does this give me test crash analytics for my beta testers, but when this application is submitted to the store and I have it in production, I will be able to see those crashes inside of the HockeyApp portal for my production package. So if I go to app.xaml.cs, I can see the singular line of code that was added. Microsoft.hockeyapp.hockeyclient.current.configure with some GUID. And so now I can return to HockeyApp. I can view crashes. In this case, I don't have any crashes yet. But when this app is published to the store, I now have live usage data, live crash analytics, and everything I could really need for just a single click. The one thing that you will want to take note of, when you do a production build of this and you submit to the store, HockeyApp will not know where your symbols are. You can download the symbols from the store for debugging those crashes, and then upload it to HockeyApp. And then HockeyApp will then have a reference of those symbols to that package. Now, I want to return to the PowerPoint to wrap up, which I think is it. So all that was left was demos. You saw the app design, UI analysis, SAML edit and continue, and distributing with HockeyApp. So I will be posting a link to the GitHub repository that hosts this sample, and it provides some instructions, including a schematic of the IoT device if you want to build this yourself. You'll be able to see that at either the recording of this video on Channel 9, or if you follow me on Twitter at PM@Mike, I will be posting it there shortly after this. Any questions? All right. Yeah, question?
So for the dump, the client,
Yep.
give you permission to send the dump, or it's automatically collected
Do you need permissions to send the dump, or is it automatically collected? For the store or for HockeyApp?
for the store?
For the store. So the store doesn't currently collect dumps yet, but that's something that we're looking into and how we could do that without any sort of privacy concerns.
So in the case you collect the dump, what's the debugger for you to use to run that in the Visual Studio to manage?
Yeah, you can use Visual Studio.
Is a new debugger or is a...
I think it's the existing debugger, but I can get back to you in a sec. I'm not entirely certain. Good question. Any other questions? All right, I'll stick around for a couple minutes if you want to ask me anything personally. Otherwise, thanks for joining.